What did you get, Charlie Brown?
I got a rock. I got a rock. Rock. I got a rock. 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 I got a rock. I got a rock. I got a rock. Rock. Rock.
What did you get, Charlie Brown?
I got a rock. I got a rock. 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 I got a rock. I got a rock. Got a rock.
What did you What did you get, Charlie Brown?
I got a rock. I got a rock. 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 I got a rock. I got a rock. Got a rock. Got a rock. 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 I got a rock. I got a rock. Rock. I got a rock. I got a rock.
All right, so last week we left off starting with strings, and we looked at a couple of ways of manipulating strings in both C and Java. We left off with talking about these byte-limited versions of strncpy, which again is string, CPY is copy, so we're going to copy one string into the contents of another string, but we're only going to do it a certain number of bytes. That's what the N stands for. Copy only N bytes over. And strncat, where we're only concatenating a certain number of bytes over. Now again, if either of these functions sees the null terminating character, it will take care of it for you. If it doesn't, then you need to take care of it yourself. For example, we started out with Christopher here, and I just wanted my short first name, Chris. And so we specified to strncpy that I wanted only 5 bytes. But you don't see the null terminating character in the first 5 bytes over here. So consequently, it's not provided for you by the strncpy function, and we have to manually put it in. Right? And you can do that with any single character using the single quotes, just assign it like you would any other array. Right? And then we saw this in action here. Let's see, demo.c. Right, there we go. There. That's referred to as a substring. You've got a string, and then you've only got part of it. That's a substring, this part or that part or that part. What I want to do now is I want to show you that it can actually be much more powerful. Substrings don't have to begin at the beginning, right? you can manipulate strings to get a substring that starts anywhere in the string. Right? So what I mean by that is, let's come over here, and we'll keep the same code as before, but I'll go ahead and go with my first, my full name here, right? Christopher Michael Burke. There we go. Right? And let's, instead of the first name here, we'll go ahead and go with my middle name. I want to get just, I want to isolate just this, this string right here from that larger string. So in other words, I want to start in the middle. So we want to copy Michael instead. Oh, there we go. Into middle name here. Right? So if I went middle name and full name right here, remember it does go right to left. So the thing that you're copying from goes to the thing on the left-hand side. This is the destination right here. This is the source. Why? Because it follows the same conventions that we've been using up to this point of the thing on the right-hand side goes into the variable on the left-hand side. Okay? And then, let's go ahead and print these out. There's print full name there and middle name. There we go. And my middle name is 1, 2, 3, 4, 5, 6, 7 now. Right? Okay? And because we don't see the null terminating character in any of that, we need to take care of it ourselves. So middle of 7 is equal to the null terminating character. Now this is not going to get Michael, is it? Instead, what is this going to do? It's going to get Christo, right? The first 7 characters of my full name here. I want it to start right here, though. So where would that start? I think it's going to start at, let's see, there's no character counter here, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? I want it to start actually at the 12th character here. Well, the 13th character, of course, the, oops, not that one, full name, the 13th character, but the thing at index 12. Right? Now, is this even going to compile? Nope. Why not? strncpy requires that you're copying from a const char star, a string. Is this a string right here? Full names of 12. What is that? That's just that capital M right there. Right? It's a regular old char. Right? So there's a difference here between a char x and char star y. One of those is a regular old variable, and one of those is a pointer variable. What we've got here is the full name of 12 is a regular old character variable, but strncpy is expecting a pointer variable. So how do we change this single character into a pointer so that we can pass it? Ampersand. Right? Now let's take a look at what this does. Right? Perfectly compiles here with no warnings, by the way. That is how you do it, right? And we'll understand why here in a second. And there, Michael, right? 7 characters. Now, why did this work? What is full name? Full name, the variable, it's just a pointer, and it's pointing to the beginning of this full name right here, okay? And all I did was say, okay, well, give me the 13th character, which is right over here, and then make a pointer to it instead, right? And so it's like it's pointing at the beginning of the middle of the string, and I'm specifying whatever you do when you copy things over, start in the middle of the string and then proceed, right? And it only copies over 7 characters. We have to take care of the null terminating character ourselves, but otherwise it's perfectly fine. Right? In fact, Valgrind will come up with no errors at all in this. Right? 0 errors, 0 contexts. Okay? So you can use this to do substrings even in the middle of a string. I'll go ahead and put that in the notes so you have it. See, there we go. All right. And now let's one miscellaneous thing before we move on to Java here is that there's this other library called CType, and you might have seen this before, maybe. If we had Zybooks in this section, then you might have seen it. But you may or may not have seen it, but now I'm going to draw your attention to it. C-type library has a lot of useful functions for individual characters. For example, if you have a single character and you want to say is it a space character, in other words, a space, an n-line character, a tab, right? It'll return true if it's a space character. Is upper, right? Is lower. It'll return true if it's an uppercase letter or a lowercase letter. If you use either one of these on, like, say, punctuation, like an exclamation point is neither uppercase nor lowercase, so both of these things would return true, return false, excuse me. Right? You can also convert things to upper to lower. Right? What else is in that library? RTM, right? C-type library functions. Right? Tutorials point good enough. Right? Is alphanumeric, right? Is alpha checks whether is alphabetic, right? So lowercase a through lowercase z, uppercase a through uppercase z, etc. Is digit, right? It is lower to upper, etc. Right? So you've got a lot of these little functions here that will operate on single characters. Again, single characters, C. So you could go through and count up the number of spaces in a string using these things. Count up the number of white spaces, that is. Okay? All right, so what about strings in Java? We've already seen it, right? A little bit. That strings in Java are a built-in type. They are a class string, and the class itself is the library itself, right? We've already seen that that we have a string. We've already seen that they're immutable, right? That they're not null terminated. You don't have to do a manipulate. Sorry, there we go. There's a string library in the sense that there's a collection of methods in the string class. If you have a string and you want to convert it to all uppercase, that's one thing that we did last time, right? If I've got my name here to uppercase, it doesn't actually convert the string. It gives you a new string that is an uppercase version of the old string that you have to capture here. Foo. Because strings are immutable. Once you've created a string, you cannot change it. You can call the methods on it to create a new string that's an uppercase version of it, and then put that into another variable, but you can't change the contents of a string. And as we've already seen, again, the way that it actually implements a string is a bunch of bytes, right? Kind of like a char, but because it's Unicode support, you need bytes instead, because a char is a single ASCII character. Actually, no, it is a single, I believe that it is a Unicode character. Well, we can test it really quick here. I don't have any emojis here, but char smile is equal to smiley face emoji. I'm pretty sure that I'll just grab this one right here, copy, and paste it right there. Yep. And, oh, nope. You don't like it. Why not? Ooh, cool. System.out.println. So I learned something, we confirmed here, smile, that characters are in fact ASCII characters. Right? That you can't do that. You can put that into a string because strings use bytes. Right? And you know, smileys and emojis and all that other stuff, we got CJK fonts, they use more than 1 byte, up to 4 bytes actually, to UTF-8 here, this Unicode 16, to represent their values, basically. Okay? In fact, they call it value. All right, so they're immutable. Once you've created it, you cannot change them, but you can call methods and create new strings all you want. You can concatenate them, right? So what's concatenation look like? If I've got string last name, right, equals, there we go. Then string formatted name, I'll go my last name plus comma space plus my first name, right? And then print that out. Whole lots of strings are created there, right? There's a new string for last name. There's a new string here for this static string right here. There's the string from before, and then we create a brand new string right here, and we print out my name in a formatted manner. Right? So no memory management, no null terminating character, none of that stuff. You can put in null terminating characters if you want. Right? Don't do that. Right? Why wouldn't you want to do that? Let me go ahead and show you why. Let's go ahead and leave it like this. System.out.println, right? Name.length. .length will tell you how many characters are in that string. Just like strlen will in C, that tells you how many characters. There are 1, 2, 3, 4, 5 characters, not including the null terminating character. In this version, it's going to be, oops, should be 5. Oh, I didn't save it. It should be 5, right? CHRAS. But what happens when I put in a null terminating character confusing C in Java? Now it's 6. Even though, does it get printed out? No, because the null terminating character is not a printable character. So it's telling me that there's a null terminating character in there. It's just, this is Java. We don't care about those things, right? So don't do that, right? Don't put in null terminating characters in Java. Don't confuse C in Java, okay? So concatenation is a simple plus operation, etc. There's not null terminated. You don't use null terminating characters in Java. All right, there we go. As we've already observed, oops, sorry, got a whole bunch of things that are coming up here. There we go. There we go. All right, sorry. All right, in Java, strings are immutable. Once created, you cannot change them. Right? You can only create new strings, right, that are changes, that are different strings from what you're using. Right? You can use the assignment operator to create a new string. You can also use, as we've seen, the plus operator to automatically concatenate strings. Now, the way that this actually works under the hood is that your code is actually being changed. There is no plus operator. What the Java compiler does is it goes through, and anytime it sees a plus with two objects, it replaces that with a function call, with a method call. In fact, the thing that it uses to do that is called a string builder, which we'll look at here in a moment. You can use that directly. Right? You can iterate over each character in a string, by using ... Let's look at that really quick, I guess. We'll do it on this large string right here. So I want to iterate over each character. How do I go about doing that? Well, for int I equals 0, I is less than formatted name dot length, right? I plus plus. I want to get each character at the ith index. You can treat them like an array, more like a list, actually. If you want a character, C is equal to formatted name dot char at I. And that'll give you an individual character. System.out.println C. And that will iterate over each individual character in that string right there. So if you want to, you can iterate over each individual character. But what's more interesting is the thing that I just mentioned, that, there we go, that you've got, that you do have a mutable version of a string. Let me go ahead and get rid of all of this. It's called string builder. String builder, and I'll just say that this is SB, is equal to new string builder. Now you can manipulate the contents of the string builder because it's what's called a builder pattern. You create it initially, you manipulate it, you change it, you do whatever you want to with it, and once you're done building it, then that's when you dump it to a string, an immutable string. So for example, I'll go ahead and say sb.append, right? My name, but with a lowercase c, and then you can go sb.append as many times as you want. Now, let me go ahead and system.out.println print this as we go along. SB, right? I'll print it with just my first name, then space, sb.append, my last name. There we go. And so you'll see that it actually is changing. Right? We go from Chris to Chris Burke. Right? And oh, I need to correct that C there. I need to correct that lowercase c and make it into an uppercase C. How do I go about doing that? SB dot, isn't it replace? Yep. Replace, yeah, I guess it's going to be replace. starting at 0, ending at 1 with C. There we go. I think that that's how it works. Otherwise, we'll have to read the documentation. Oops, nope. Okay, so now we're going to have to read the documentation. Replaces the characters in the substring of the sequence with characters of the specified string. Specified string begins at the specified start and extends to the character at index n minus 1 or to the end of the sequence. So it should replace it, right? Maybe, what was it again? Start, end, and I want to replace it with string. 1, 2. Nope. SB dot, okay, so SB dot, I'm going to have to look at something else. Char at characters, code point, compared to delete. Delete char at. Is that really that stupid? I saved it. Save it, save it, save it. You're right, thank you. Duh. All right. You know, there should be, I think that there's an option that every time you run it, it saves automatically, but it's not enabled right now. And maybe it's because I'm used to that. And but in any case, there we go. So I've replaced 0 through 1, 0 through 1 minus 1, right? So it's only going to replace that one character with that sequence right there. Right? And if I want to replace other things, for example, I don't want Chris, I want Christopher, then I will replace 0, 1, 2, 3, 4, 5 through 6 with Topher. There we go. And it should insert it. Yep. And maybe only up to 5. Oops. Because I want to retain that space right there. Right. Oh, once you are done, building your string, doing whatever you're going to do with it, what you do is system.out.println. Oh, actually, no. Let's save it off into a string last. String name is equal to sb.toString. It finalizes the build and gives you an immutable version of it. And then you can go ahead and print that out. So it gives you a nice way to build up a string, to manipulate a string, to change a string without having to only create a new string every single time. And by the way, again, this is what Java will do when you concatenate stuff. If you've got a string, concatenate, string, concatenate, string, concatenate, all it does is it replaces it with code that uses a string builder. String builder, dot append, dot append, dot append, dot append, right? So it's your compiler doing that magic for you, right? If you want to use a string builder directly, you can, instead of using plus, plus, plus everywhere, right? So mutable strings in Java, string builder. There we go. And again, a lot of what Java does is going to be opaque to you. It doesn't matter. You just use plus, plus, plus everywhere. It'll replace your code for you, right? But that's a mutable version of strings if you want to. Okay. All right. Questions so far about playing around with strings? Okay. Then let's come over here and let's test something out. So char fruit 01 is equal to apple, right? Char fruit 02 is equal to orange. I want to compare apples and oranges. Right. So are those two strings the same? No. Can I do something like this? If fruit 01 is equal to fruit 02, then printf %s and %s are the same. And what I'll do is I'll print out fruit 01 and fruit 02. There we go. So now this should print out what? Well, it shouldn't print out anything. Let me go ahead and provide an alternative here. Printf, same thing, but I'll say that they are different. Right? There, now it'll print out something, right? It'll print out that apples and oranges are different. Okay? What about comparing apples to apples? Are they the same? Let's find out. I mean, conceptually, are they the same? Apple, apple. A-P-P-L-E, A-P-P-P-L-E, right? They should be the same, but they're different. Why? What is this thing doing right here? What is it comparing? So let's rethink what these values actually are, right? Fruit 0, 1 is an array, right? It's a char array. It's a pointer. So what I'm asking is this pointer the same thing as this pointer over here? Right? Are they pointing to the same thing? In other words, do I have a shallow copy? That's what I'm testing here with this equals equals, right? And certainly they're not, because they're completely different memory spaces, right? Fruit 0, 1 is a pointer to pointing over here with contents APPLE, and fruit 0, 2 is a pointer that's pointing over here with the same contents, okay? So using equals equals will not compare the contents of a string. Right? It compares memory addresses. Right? That's not what I want. What I do want is a way to compare the contents. Apple, apple, these are the same thing. This string matches this string over here. Now to do that, I'm going to have to bring in a library function in the math library. Right? So int result is equal to strcmp of fruit 0, 1 and fruit 0, 2. There we go. So what do you think strcmp is short for? String, CMP? Compare. I'm going to compare them. Now we'll talk about what the formality of what it returns here in a moment. The result is going to be something negative, something positive, or 0, depending on the relative order. So what I mean by that is if the result is less than 0, that means that fruit 0, 1 comes before fruit 0, 2. Printf %s comes before %s and the line. Fruit 0, 1, fruit 0, 2. Right? And that makes sense because think about the number line. Right? You've got negatives over here, 0 in the middle, positives over here. That's a relative ordering, right? If they're in order, I'm going to return something negative. If they're equal, I'm going to return 0 because they have exactly the same contents. If they are out of order, I'm going to return something positive, right? The less than sign here corresponds to the less than sign if you could compare these using the normal less than or equal to signs, right? That fruit 0, 1 comes before fruit 0, 2. Right? Otherwise, if it's 0, else if result is equal to 0, then they're the same. Is equal to fruit 0, 2. And the only other possibility is that the result is greater than 0, in which case, think about it this way. Fruit 0, 1 is greater, it comes after fruit 0, 2, right? So printf %s comes after %s. And same fruit 0, 1, fruit 0, 2. There we go. All right. So apple and apple, we should expect what? Which one? That they're equal, right? Apple is equal to apple. What if I go back to oranges? Orange, there. Apples and oranges, which one comes first? Which one? Not in your favorite, but in a dictionary, right? Apple comes before orange. Except that, wait a second. What if I go capital on this one? Which one's going to come first? Oh, sorry, wait, apple comes, what if I go like this? Capital on O, there we go, that's what I want. All right, which one's going to come first now? Apple comes after orange. Lowercase a apple comes after orange. Why? Let's change this to uppercase and see what happens. Apple comes before orange now again. Why? ASCII texttable.com or ASCIItable.com, right? Look at all of the caps. Where does big O come? Where does capital O come first? 79 versus lowercase a, which is 97. So how is it actually comparing stuff? It's comparing it not alphabetically. If you were to open up your dictionary, everything in there is alphabetic. It doesn't matter if it's uppercase or lowercase, right? All the A's come first, right? And all the Z's come last. Here in this case, however, it depends on uppercase, lowercase. Right? That we call that not alphabetically, but we call that lexicographic. Right? This is comparison by compares lexicographically using the ASCII table values. Right? So uppercase, all uppercase letters come before any lowercase letters. Okay? What happens when we've got a plural form? Apple and apples. Now, dictionary form, which one would come first? Apple, right? Why? Because it's the shorter one. Right? So that's, we're going to see that here as well. Apple comes before apples. Okay? And bananas, right? Which one comes at first there? Apples comes first. Bananas comes after apples because lowercase b. But if we uppercase it, then now bananas comes before apples. If you don't want lexicographic, right? If you want to compare without regard for upper or lowercase, you can use result is equal to str case CMP, fruit. And I'm going to copy the rest of this stuff. There we go. So what that does, it ignores case. Right? The uppercase, lowercase, it doesn't matter. Banana comes before apples now, but when I ignore the case, bananas comes after apples, even though it's uppercase. Okay? So if you want to compare without regard for upper or lowercase letters, then you use str case CMP. If you want to compare a substring, if you want to compare only a certain number of characters, you can use str ncmp. Right? Remember, we have strncpy and strncat. Those are going to limit it to only a certain number of bytes. You can do the same thing here. If I only want to compare, say, the first three bytes, first three characters here, or apple and apples, 1, 2, 3, 4, 5. Yeah, let's go with 5 there, right? Now apple and apples will become the same string, right? Apple is equal to apples when you only restrict it to the first 5 characters. Right? And you can use the same trick that we just did on substrings to compare a substring as you go along. Right? So a lot of things that you can do here, right, with very simple comparison operators. But you cannot, the takeaway here is that you cannot use the equals equals operator here. Okay? So to review string comparisons in, say, C. Right? In C, you cannot use the equals operator. It compares memory addresses, not contents. Right? You need to use strcmp, strcasecmp, or strncmp to compare contents. Right? And let me go ahead and put in the code samples that we just did. There we go. But let me go ahead and expound on that. Right? So it is a comparator pattern. Right? It returns something, and I'm going to emphasize something here, negative, if A is less than B. Right? It returns 0 if A is equal to B. Right? Again, conceptually. Conceptually, there we go. And it returns something positive if A is greater than B, right? Or equally if B comes before A. Right? So that's a comparator pattern. It returns something negative, something positive, or 0, depending on the relative ordering of these two arguments, A and B. Are they in order? Negative. Are they out of order? Positive. Are they equal? 0. We're going to use this comparator pattern all over the place. In fact, every single programming language uses this pattern to compare things, right? There's going to be some sort of function that compares strings. Some languages do allow you to use an equals equals operator. Some of them require you to use equals equals equals. But most of them, especially for user-defined types, if I've got a student and I want an object, right, concept, how do I compare them, right? Do I order them according to their last name, first name? Do I order them according to their GPA, ascending, descending? How am I going to order these two things? You need to make it abstract. You need to make it general, and the way that you do that is by following this comparator pattern. These are just two things, right? Are they in order, out of order, or are they equal, right? Because I want to sort it, or I want to swap them, or I want to have a relative ordering that this one comes before that one, right? And that's a comparator pattern. Every single programming language is going to have something like this. In fact, Java does too. So, string fruit A is equal to apple. Right, there we go. String fruit B is equal to orange. There we go. And what happens if I do something like this in Java? Fruit A is equal to fruit B. Printf, or system.out equal. There we go. So, compiles, right? Else system.out.println not equals. Not equal. Let me go ahead and run this. What's it going to say? Of course that they're not equal because apple and orange are different. What if I did something like this though? Apple and apple. I'm going to cross my fingers here because it's actually going to lie to you and say that they are equal. What's happening here is compiler magic. What it does is it sees, oh wait, you created two strings with exactly the same content? No. I'm only going to create one on the stack or in the heap or whatever, and I'm going to make both fruit A and fruit B point to it. Because there's no need to create two distinct strings if they have the same content, and strings are immutable in my language, Java. So the compiler compiles all that away. I'm going to force the compiler to actually make a new different copy, a new string. Right? Apple. There we go. Now, these are two distinct copies in memory. Apple over here and apple over here. But it's going to say that they're not equal because, again, it's comparing memory addresses. That memory address over there and that memory address over there are not equal, even though they have the same contents, right? So how do I go about, and let me go ahead and just be consistent about it and create a new string here, new string here. That's kind of verbose. You wouldn't actually do that in practice, right? Well, again, that's the compiler magic taking care of it for you. If you just type string is equal to foo, right? It's actually probably replacing it with a call to the constructor like this. This is just syntactic sugar that allows you to write a little bit less verbose Java code. Right? All right, so how do we do this like we did in C? Right? So if fruit A dot compare to fruit B. And again, it's going to follow this comparator pattern. Right? If this is less than 0, then I will print out system.out.print. And I like using the same formatting here, so %s comes before %s and the line, fruit A, fruit B. There we go. Otherwise, else, if, and let me go ahead and put this into an integer here to show you that it is indeed an integer, right? You're going to compare that one to that one. And so if the result is less than 0, else if result is equal to 0, system.out.printf, they are equal, equals, else. And now, remember in the C version, I did put else if result is greater than 0. I'll go ahead and do that here too, but is that necessary? Something is either strictly less than, equal, or greater than, right? So you don't need this else if. It would just be an else in general. Right? But I'm putting it here for demonstration purposes so that you can see that indeed there are only these three possibilities. Comes after. Oops, after. There we go. All right. Now when I run this, they're not equal, of course, because they're two completely different memory addresses, but comparing them results in 0. They have the same content. If I went with banana, right, banana would come after apple. Right? But like C, it is going to be used, let's go with big B banana. There we go. Big B banana is going to come before apple because it's lexicographic. Right? How do you do it without regard to case? In C it was str case CMP. In this one it makes a little bit more sense because the function is called dot compare to ignore case. Right? It's more explicit. Ignore the casing. Ignore the uppercase and the lowercase. This one over here in C, it's kind of misnamed, right? That tells me that string case comparison tells me that it is case sensitive, right? So, but it means ignore case. It's just the opposite. Over here, it's a little bit clearer. Right? How do you do partial matches? Well, that requires doing substrings in Java, which we didn't talk about yet. So let me go ahead and bring this over here to Java. Same exact concept, except you use the compare to and compare to and ignore case, compare to ignore case methods. Right. So Java. There we go. All right. Compare to ignore case. Yes. Compare to. And in other words, you have to have an object in order to invoke that function on. Right? Why? Because in Java, everything is an object or belongs to an object. You just can't have this function sitting out in the ether like strcmp is sitting out in the ether. Right? It's a globally scoped function. Last thing I'll show you today is substrings in Java. Substrings in Java. So what we had to do in C is we had to change the pointer to a midpoint in the substring, and then we had to call str cpy and cpy to get it, well, just part of it. Right? So if I have, say, string full name is equal to Stouffer Michael Burke. There we go. What I want is just my first 5 letters here. String first name, short, is equal to full name. And guess what? We have dozens upon dozens upon dozens of methods that we can act on, including substring, right? So substring here will, there's 2 of them actually, that you can have specify a beginning index and an ending index. So let me do that. Where should I begin? I'll begin at 0. Where should I end? I just want the first 5 letters here. So let's try 5 and see what that looks like. System.out.println, first name short. My goal here is just to have my first name Chris, right? And why are you complaining because of that? There we go. All right, and let's go ahead and run this. Chris, right? It works. Well, wait a second. 5. You went to C, which is 0, 1, 2, 3, 4, 5. Why didn't it include T there? Let's read the documentation. Right? Returns a string that is a substring of that string. So the substring begins at the specified begin index and extends to the character at index -1, end index -1. Right? It's off by 1. Thus, the length of the string is end index minus begin index. And that's why it looks like this, because I want a substring of length 5. Right? Well, that means that if you start at 0, you go 0, 1, 2, 3, 4. Right? It makes sense if you think about the length of this. 5 minus 0. That's the length of the string, 5. Right? What if I want it starting at Michael instead? String middle is going to be, where do I start that? Where did we start it before? Was it 13 or 12? Full name, let's find out. dot substring. I'll start it at 13 and Michael. So all I have to do to know what the end index is to add 7 to whatever this is. And I'm not sure that this is correct, but we'll find out in a moment here. I think we're off by 1. Yep. So it was actually 12. And I would add 7 to it to get 19. There we go. There's my middle name. Right. What if you want a substring that goes all the way to the end? That was the other version. So string foo is equal to full name dot substring. If you just want to have one beginning index, say at 12, it'll extend all the way to the end. Right? Foo. There. There, Michael Burke at the end. Right. Now, that is only a small subset of the functions that you have available to you. Full name dot, right? You can get characters. You can compare things. You can get their byte versions. You can find the first instance of a particular character. So where's the first capital C? You can get the last index of whatever you're looking for, et cetera, et cetera. You can actually change regional encodings and things like that for like foreign languages and stuff. Starts with substring, subsequence, to lowercase, to uppercase, transform, trim. You can trim out white space, beginning and ending white space, et cetera, et cetera. So lots of things that you have available to you in the standard string library. 90% of the time with C, 80% of the time with C, what you're trying to do, probably there's not a function. But there's a function in the standard library, a string library, that you can use and modify and combine with other functions to get exactly what you want. But 90% of the time over here in Java, it's built in already. Right? So look for shortcuts by using that string library to its fullest. Okay? Right. Any questions? No? Any questions in general? The midterm was posted. The midterm results were posted, that is. We'll have Hack 7 within an hour here posted as well, and then a midterm grade checkpoint, right? So, no? I will say in person that this is one of the better H sections in a couple of years. In terms of grades and outcomes, so good job. You're probably the first full, post-COVID students, and so we're back to normal now. Apparently, I don't know. All right, so I'll see you on Wednesday then. We still.